Hello everybody, and once again we're back with another engine video that is boring, no cut, no editing, no cut on the DVD. Back to our engine work straight away. File from last time, the CSV, open with open office, calc, make sure you separate by comma and you're in the ballpark. Oh my god, I wonder who made such a neat CSV engine profile. Damn, I don't even know who would that be. Now, just from looking at it quickly, those that might not know what's going on, we're working on engine 11 and 12. Those are qualifying in race engines for CTS physics. As you can see, it's all in plain, as plain as day right here. And all these engines are in the chassis 1, 2, 3, 4, 5. Well, everybody knows that. Two things I want to talk about. You see already I have dialed in mechanical dimensions of the engine, such as number of intake valves, number of cylinders, the size of the engine, the stroke, and red line, which is the rev limiter, pretty much the electronic cutout and shit. Anyway, those of you that understand what an electronic rev limiter is versus natural engine's red line when it's about to explode or runs out of breath, this is the electronic red line. If you set this higher, the engine will probably go higher than that most of the time. Anyway, that's some more science shit for later. So all these dimensions, I'm going to outline them in yellow for those of you newbies that are just joining. These are real life dimensions. You can straight copy paste from online stats. Basically, if these are not correct, you're not making the right engine as far as it goes. In the big EXZ, I've not found any extra engine lines between the engine profiles. So I guess this is what we got. There's nothing else there hidden. That's some space level shit that iRacing might trip about if I show you. So I'll keep that for later. Now for the second part. Newbies, real life dimensions, newbies, say hello to each other. For all you pros that are listening, torque 1 and RPM 1. There was a lot of questions about that. And I'm here to answer what I know, what I think. From horsepower point of view and power point of view, at 0 RPM, you're not making any power because the engine isn't spinning. However, to prove the Bmep theory that I have been talking about, Bmep is basically the size of explosion in PSI that are acting on top of your cylinder, on top of your piston. So the bigger the explosion, the bigger the Bmep value. The bigger the bang, the more power, the more fuel you burned. That's what it means. The more air you ingested. Assuming. Um, Now, when does that happen? With the very first bang, which could happen at 0 RPM. At 1 RPM, the very first compression stroke, boom, and you exploded and you got your first BMEP. So that explains why the number is 0. However, our engines idle at what, 8,800 RPM, 600 RPM. So a little Mickey Mouse fix for some of you. I have not tested this. I just want to say, what if you set the RPM 1 to your idle and see how that go? Anyway, that's more for testing. For now, we're talking about torque 1 and what would be the number and how to get it. Well, obviously, what I could tell you from here is that torque 1 has to be less than your torque 2. Your torque 2 is your maximum torque. So if your maximum torque would be here, then the engine stats online or whatever, whoever's advertising the engine stats, he will post maximum torque at 0 RPM. You know what I'm saying? So maximum torque is maximum torque for a reason. It's the biggest BMEP that you get. So rule number 1, which is concrete solid, I'm almost 99.9% sure that torque 1 cannot be bigger than torque 2. Can it be bigger than torque 3? That's a possibility, depending on the engine profile. So if you take a look at any engine torque curve, engine, suka, torque curve, torque, come on. Okay, there you go. A good value. As you can see, dyno here starts at 1000 RPM. Usually the dynos start at 2000 RPM because, this low RPM does not matter that much when you're trying to find out your maximum torque and maximum power. However, Um, Rule number one: you just kind of guesstimate and kind of just follow the line and try to draw it like in paint or something and see where it lines up, like somewhere right there. So this would be somewhere around your torque 1, I would say. Now, most of you are going to mention this to me right now. There is no burnout in the game, so you're not putting so much power into the wheels at the beginning. That's why the game is lacking burnouts and all that garbage. However, I think it's in the tire section, and they've done something to the tires. And it's if there's no burnout, look in the tires first. Don't look at the fucking engine and blame the engine first and say the engine is broken when your tires aren't burning out, because the engine shows good data and good torque curves and everything mathematically works out. So there you go on that. I think it's in the tires, and you should mess with the tires if you want burnouts. If you want engine, you look in the torque curves and the replay analyzer data, and whatever torque it shows, that's what you're getting, and there's no room for argument there. Now, those of you that finished, I mean, followed till this so far along this video, no cut on the DVD. I'm just talking because I don't have time to edit videos and make them cool and exciting. I just want to talk about stuff that I know and get some things off my chest if something new pops out. We are going to Engine Analyzer Pro, and I've talked about the software before and made some videos and some posts about it. Basically, this is a professional engine simulator software which is available for free for 10 days. If you got 10 days to mess around with, it's free. You can get all your engines. You could script an engine down to like all the dimensions of the valves. If you have the technical data, you could build your own engine down to like everything. But how much of this is in NASCAR 2003? It could be a lot of stuff. We don't know because the EXE is pretty big. There's about 3 million lines in there. However, I see a good engine analyzer profile right here. However, you see right here it starts at 2000. In this software, you could set it to where it's going to start at 0 RPM or 100 RPM, so you're going to get your values as low as you need to be. This is number one, how to hunt for torque 1 for sure. Then let's take a look at what this game, I mean, not the game, what the software is calculating. Brake horsepower, torque, as we could see, we're making about 400 pounds of torque at 5,000 RPM and about 400 horsepower at this looks like a GM 604 engine to me. But anyway, volumetric efficiency, all you gearheads know exactly what all those things are. Those of you semi gearheads could look it up and just type in any of this stuff in Google and research. But look, this software will calculate the BMEP PSI, what we're supposedly thinking is in the NASCAR engine profile, which is so nicely done by somebody. I don't know who does such a nice and neat looking CSV profiles, but here it is right here. So basically, you download this for 10 days, it's free. If you have a spare laptop that's been running around in your closet and you can reinstall pirated version of Windows every 10 days, I'm not telling you to do it, but if you do reinstall your Windows, then you could install the software again and get another 10 days for free. Unfortunately, both of my towers are pretty useful, so I cannot wipe the memory on either one of those. So that's not the option for me. I might have to buy me like $100 computer and do that because it'll be cheaper than the $600 software. But if you got money, please support them and buy this software. It's amazing. And in that software, you're gonna set your RPM range from 0 to whatever, and it will calculate the BMEP values for you. On top of that, you don't have to calculate any BMEP values. If mathematics is not your field, if your mathematical skills are non existent, such as some other physics editor creators out there whose names I'm not going to mention, then you could just use this software and it will calculate all the BMEP values for you. So I'm gonna do both. I'm gonna download it later on, make series of videos, 10 days of Engine Analyzer Pro until it expires. And my own mathematics, we can compare the values and compare, what it's gonna say. However, if any of you know what IMEP is versus BMEP versus MEP, please leave it in comments, and I don't know, I'll buy you a game on Steam or something. If you understand exactly what we're dealing here with IMEP, FMEP, and BMEP, if you're in on the theory, and if you understand what those things are, not just BMEP, but this shit, this will put your mind in the right place for the next few videos. Anyway, for now, I think it's been fucking long enough to keep you occupied with this garbage. Torque 1. Torque 1, simply download this and it'll calculate everything for you. Let me just see if I can find an engine profile that has RPM values at like 0. Probably. Okay, there's one that starts at 1,000 RPM. You can set it at 500 or 100 RPM and it will still calculate. Look at the BMEP 110. This sounds very much like the BMEP that we have 115 right here. You know, those of you that are in the mix are understanding what it means. Those of you that aren't, sorry, but BMEP is also how cool your engine is in terms of efficiency. It calculates the engine size into it. So this tiny engine, I'm assuming this is a small engine because we're only making 193 foot-pounds of torque and about 176 horsepower. So it could be equal to like Honda RSX or something, Acura RSX engine or some shit like that. And why are we getting such cool BMEPs? Because it's a pretty efficient engine for its size. Even though it's making such a little power, it's probably not burning that much fuel making it. And there you go. At 1,000, you already have your BMEP torque 1 at 110, but I suggest you calculate it maybe like at 500. Get your numbers that way. This will calculate everything for you. Other than that, you're just gonna have to estimate and guesstimate. There's also Planck formula. I'm gonna do Planck formula in the next video just to mess around with your mathematical skills and brains, which are non-existent for some physics editors, honestly. And on that bright note, you know, keep your RQ high. Um, New NASCAR 2019 season is gonna start soon. Congratulate Joey Logano. Post a like, post a link. You know, I love you guys. Uh, Donate to me via PayPal, Praytown, whatever the name is. Send me checks, gold, anything you want, pretty much. I'll accept. Thank you very much. Bye.